Hi there, this is Jacob Nash Engineering Lessons, and this is Unit 3.1, Lesson 2 on, oh, well, this is just the main title slide. I mean, I already did Lesson 1, but I'll get to that in a minute, but right now, I'll just talk about this unit again in case you didn't watch the last video. But you probably did. But anyways, so once again, this is on programming, and it's for distance learning learners due to the 2020 pandemic. If you're watching this like years later, you're like, ugh, that doesn't even exist now. You might not even want to bother watching these videos for this unit because it might not be what you're learning, but I have no clue how long this thing's gonna last, and if it might last for years, so maybe it's a lot later than 2020, but you're still learning this anyway, so whatever. There you go. So, useful resources for these lessons: the vrvex.com site that I discussed in Lesson 1. Please watch that video if you haven't already, because these lessons 2, 3, and 4, and any other ones that there may be, I don't know if there will be more than that, but it won't really make that much sense, and I explained how to use it on that video. Also, I hope you have access to the PLTW website. I hope that your teacher probably gave you your username and password to sign into that, because I mean that's what this course was created by, so I think you'd probably have access to that site. But if not, you'd probably be fine. I mean, like, I'm not your real teacher, obviously, so if your teacher hasn't given you that, I guess you just don't need it, but whatever. I'll just be referencing things that they say on there, though, but it won't be different than what your teacher says, probably. So this is just standard 3.1.1, Lesson 2. I can't really say the exact, like, description of this. I guess I'd say pseudocode and algorithms, maybe, because that's what I'm talking about, but it's not just that, so I don't know. So first, what are the goals for this lesson? Create pseudocode to describe an algorithm. You might be thinking, oh, what the heck is that awful word? Well, I'll say what it means and how to say it, but I did say it, so I guess you already know. And also create a computer program to implement an algorithm. Algorithm is kind of a strange word spelling too. But so first, inputs and outputs. Okay, sorry about that. Robots are similar to humans if you consider that we both use inputs and outputs to sense and react to the world. Well, you might say, no I don't. Well, yeah you do. Something goes in, and as a result it goes out. So an example could be input, you watch my videos; output, hopefully you get a good grade. But also, well, I'll say the literal definitions, but an input is something that you put into a system so that it can operate. So in the case of the VR SDV, self-driving vehicle, that robot that's on that VEX VR thing, the input is the code that the blocks that you put in, and then the output is what it does as a result of that. So it's kind of like cause and effect a little bit, but not exactly, really. I mean, I guess the input does cause the output, but it's not exactly the same thing. But output is the information produced by a computer. And in this case, that's only the definition for this programming unit. So here's another example. A car going in dirty will go out clean. The input is when it's dirty, output is when it's clean. And the process that is described with the pseudocode, an algorithm, is basically the car wash itself, the water right there, I guess. So pseudocode, you pronounce that Pseudocode. You know, well, you might not know, but most PS words, pursue, like PSEU, words like that, sound, the P is silent. But, anyways, that's not the point. Pseudocode is a type of language that is between natural language, what you say, and code, specific language, and punctuation that a computer can understand. Pseudocode is often used to plan an algorithm, a finite set of instructions that accomplishes a specific task. So, an example is, in a normal language, you might say, when the VRSDV detects a green object, and that's just a block you might put in, then pseudocode, you would just say, when, oh, I left off the S, sorry about that, when the VRSDV detects green. So notice, that's not correct English, that's too vague, don't try to use that in your English class, you'll get a bad grade probably. But I left off the, a, and object, because those are just specific, vague, unneeded words for the computer. It takes up too much time to type those, and the computer doesn't. Yeah. Ooh, that's bad. Okay, I'm sorry about that. There was a crash out my window just now. Oh my gosh. Oh. Sorry about that. I don't live in a very too good area. It's rush hour right now. I'm telling you, I've seen like 10 crashes since I've lived here. But whatever. Anyways, those words are unneeded, so that's why they're not in the pseudocode, because it's very basic what's in the pseudocode. Algorithms. An algorithm is a step-by-step procedure for solving a problem or accomplishing some end, especially by a computer. So, basically, it's just steps. Probably you'd want to say your problem first, then you'd say your solution. So, but the solution would just be the steps of what you do. So, 1, do this. Number 2, then do this. Number 3, finally do this. So, an algorithm for making a peanut butter and jelly sandwich. That's a very basic example. Problem, you want a sandwich, I guess. Solution, get out bread. Get out a knife, put peanut butter on one side, put jelly on the other, slap it together, eat it, whatever. That's basically the algorithm for that. Example, using what we know. Suppose you want the VRSDV to reach the red border on the left and stop there. We did that. We did that on the lesson 1. I already showed you how to do that. But I didn't say how to write the pseudocode, so think about it. What would the pseudocode be? It would be, when started, drive 200 millimeters, turn left 90 degrees, drive forward, wait until I detects red, down I detects red, then stop driving. That sounds very basic and robotic. Well, it is. That's what's the point. You're not going to say, well, when it started, blah, blah. No. Wasting your time. Goodness gracious. Sorry about that. I'm getting pretty sidetracked about that crash. I'll just close my blinds for now. So then you can see the code. What do we do for the code? We did drive forward 200 millimeters, turn right. Well, we did say on the left, that's why. Turn left 90 degrees, drive forward, wait until. Well, that was actually a little bit different than what we did. We said if then. But in lesson 4, we'll describe the difference between repeat until, wait until, and if then. Then we said stop driving, and that thing got its life spared. Okay. Now write an algorithm. So the algorithm would be step 1, drive forward 200 millimeters. Step 2, turn left 90 degrees. Drive forward, then wait until the down eye detects red, stop driving. Sorry, sounded like there was just another crash. So we pretty much just left off the when started. So the pseudocode, like we said on the other slide, it helps you plan algorithm. Okay, end of video. Thanks for watching. Remember to like, comment, subscribe. And that's it. Next time we'll see this video. And I'm about to make it, but you won't see it because it's on the next video. So please see my playlist for Unit 3.1 programming, and there you go.